So we've got to do a little bit of thinking here of how do we get there. If they said that the azimuth from A to B is 5840, but we're going from B to A, our forward azimuth is in this direction. Does that make sense to everybody? In other words, B to A, we're going counterclockwise. B to A is what we're going to call forward. So what is B to A? What's the azimuth of B to A? Well, we know they gave us 5840. How do we get, what do we know about forwards and backwards? What do we got to do? 5840, if we add 180, correct? So if we take this 5840 and we add 180 degrees, we're going to get 23840. So 23840 is our starting forward azimuth. Does everybody see that? Crystal, you okay? Logan? You guys holler at me if you don't, right? You good? So we're going to use that for our forward. Let's go to the crib sheet. We're going counterclockwise. Crib sheet says what? Counterclockwise, it's going to be the back azimuth plus the interior angle to get a forward azimuth. So we want to head to where? So we know the forward azimuth of this already. We want to go A to E, right? So what do we got to find? We need the back azimuth of this line first. So what's the back azimuth of B to A? Well, we already know it. Yeah, we already know it. So it's 5840. They already gave it to us. So that's our back azimuth. So if we jump into the method, and Derek, I don't know if you missed last week, but we kind of went through how to walk tabularly using forward and back azimuths. Makes it a lot easier than dissecting angles. So in this case, we said we're going to take the back azimuth. What's crib sheet do? We got to add it, right? Back azimuth plus the interior angle gives us the forward azimuth. So 5840 is our back azimuth. The interior angle is 101.28. So if we add them together, the new forward azimuth of this guy that we're working on here is 160.08. So I'll let that digest a little bit. Did everybody see how I got that?
How did we find the interior angle?
That was a given.
It was given? Okay.
Yeah, that was given. So in our simplified process, we're just using the formula. The back azimuth plus the angle gives us the new forward azimuth.
Okay.
Once you work through one of them, that's why I say you missed last week. This is an easier. Does everyone agree this was easier than trying to dissect those angles? We're just dealing with 180s. Is pretty much.
Do you have a crib sheet for that with those?
Yeah. You know what? I think I got one.
I like formulas.
Yeah. No, and I think.
Plug and chug.
I hope everyone would agree. I went through the dissecting the angles in that first round, just because it's necessary. Derek, I don't, but I will make you one. How about
Okay.
that? I want to run. I'll run up while we're on break. I thought I had it up. Yeah. But we could put it right here. So let's just say when we're doing counterclockwise, it's going to be the back azimuth plus the interior angle equals the new forward azimuth. We said we have the forward azimuth. To do the formula, we need this line's back azimuth. How do we get that? Add 180, yeah? Everybody okay with that? So we had this forward azimuth from A to E at 160.08. We're going to add 180 to get its partner, the back azimuth, 340.08. And then we can do it again. Now that we got the back azimuth, we can use the formula to find the forward azimuth of this one. So we said, let's take the 160.08. We got the back azimuth 340.08. So 340.08 plus the interior angle, 458.42 is this one. Now, that looks a little strange, right?
Do they usually give you the interior angle?
Yes.
Okay.
Yeah, in this case. And think about this. So, and we're moving ahead. Think about the traverse that you're going to work on in the parking lot. You're going to be able to measure a distance here, but you're also going to be measuring that angle. So you'll be able to, in your traverse, you'll be finding those angles on your own. This looks a little strange, right? This 458.42, it's huge. you could keep using this and going around the traverse and keep these real big numbers big, but what does it look like I did here? I just got this back to what, 360? I took 360 off of this to turn this kind of into a normal azimuth. So 9842 would be the normal azimuth for that line. And then you just kind of keep working around. So we just kind of, Sam and I worked a little bit on this earlier today, just try to get this counterclockwise flow. But you're going to use the same process.
How did you get the 9842?
9842, Crystal, this would be 458's are real big. That's huge, right? So if we took 360, so we just said let's get it down to a regular. So if you took 458.42 minus 360 degrees, that's what it would be without that big increment.
Okay.
Does that make sense?
Yeah.
So then same thing. How do we get the back azimuth? What do we got to do here? Just do one more here. Add 180.
Mm-hmm.
Yep. So let's go 9842. 9842. I'll add 180. $278.42. So that's the back azimuth of D to E, or E to D. So what do we got to do? We want to find the forward azimuth of D to C. Add or subtract. We're going to add. Just follow the formula, right? So let's add 113.05. Let's see what we get. D to C. So again, real big number here, right?
So if it's over 360, basically just subtract.
Subtract 360 off. You got it.
Okay.
There's right. So 391.47. I'll squeeze this in here. 391. So if we'll take 360 off of that. Let's get it back to something smaller. 31.47. Should we finish it? Why not? Why not? We're here. $391.47. So I'm just going to take 360 off of this here. This is forward azimuth of D to C. Okay, what's its back azimuth? Add 180, yes? Yes, yes. Add 180. To 1147. What's that angle? What's it? 104.42? So formula says we add it. Let's add it. Add the interior angle, 104. Oops, is that right? Yeah, 316.29. C to B. 316.29. That's as zoomed out as I can go here. So 316.29, let's bring this up here. 316. What do we do to get back azimuth? In this case here, what do we think? We could add 180, but we could also subtract 180, right? If we added 180, this thing's going to be monstrous, but we could subtract 180 to find this. That's that one thing we talked about last week. Hi, Chris. Didn't see. I got my head buried in here. I didn't even see the working. That's the one little piece of looking around at the 360 versus the 180. We can't just follow the formulas. We do kind of have to think about it a little bit. So 319, let's swing this over to get the back azimuth. We'll take 180 away. Is everybody okay with that? I mean, you guys kind of see how it's that little piece of just, hey, what do I need to do with this? It's not.
I mean, would that basically be the same as adding it and then subtracting 360?
Exactly. You're, Derek, 100% correct. So 136.29. That's our back, and we can finish up here. So 136 degrees, 29 minutes. C to B. So the last move we have is let's follow the formula. Let's add the interior angle. $238.40. Forward AZ of B to A. I will admit it, I'm doing the math here and I'm thinking, oh, I hope this works out. But it is. This is another one of those problems where we said you can check yourself. You know if you got 0 points or you got 100 points on the quiz, because you have to check. It'll have to balance and close. You know you got it right. All right.
That last one was basically your check. You're looking back. Okay.
Yep, becomes the check. With these forward azimuths, we can then calculate the bearings if we needed to, right? I won't go through the process, but we can just use that formula sheet. I know I got that one here. Because we have all the forward azimuths for everything. Hopefully everybody's keeping this one handy. So we can convert all those azimuths to bearings if we needed to put bearings in. That's good. Okay? All right. Okay, so I'll make a copy of this and leave it by everybody's desk here today, so you got another example, another crib sheet to work off of. All right, let's look at, since we didn't get a good turnout on problem 8.12 and 13 and 14. First, we were talking about today, we're going to go in the field and actually shoot a traverse. Points are out in the field. So 8.12, 8.13, and 8.14 are kind of the template for what we're going to be doing outside when you get your shots and stuff. What I thought I would do is, everybody okay? Kind of move. I know I'm moving quick, but at the same time, I want you guys to get out in the sunshine and be able to get your shots and come back in and work on the problem. 8.12. Here's what I did. I got 8.12 set up. And 8.12 is that's your homework assignment for today, or it was due today. North, this was given as 64 degrees, 40 minutes east. We haven't gone all the way through the table yet and done what's known as the compass adjustment, and we can talk about that. I think we touched on it when we first started working with this table, but what do we say? This table gives us the ability to input our data of what's known. We can input either bearing or azimuths. We know we worked on cosine and sine in that first week of using the bearing angle to find out that distance. What is our latitude and what's our departure? We're going to need to somehow balance, and that's what we can kind of work on today. I don't know whether I want to have you all work on. How about this? Do you want to get your shots outside first, and then work on that? Would you guys rather do that? Let's do that. Let's take. We'll get our shots. Eventually, what you guys are gonna be capturing today is the distances of your traverse. So you're gonna have 4 distances, and you're gonna have these 4 interior angles. That's gonna be what the goal is of the shots today. So 2, 2, 2, and 3. So we can go a 3, a 2, and a 2. So however you all want to pull yourselves together, we'll get everybody organized. Before we head out, I do want to go through a couple things. We talked about holding the prism from last week. On the list is there's an equipment list. So if you guys go to the second page, Derek, maybe for your benefit too, you guys are going to want to do this today because obviously you're going to want to hold your prism as tight as as good as you can over the point. So like we said, you just take those 2 lath. I want you to switch off. So if you're going to be working together, if there's a 4-sided traverse and there's 2 of you, you're the instrument person on 2 of them, and you're running the prism for the other 2. I want everybody to be able to participate. Like we said, just loose using these lath here to be able to just kind of loose grip. Once you get the prism plumb, this just kind of locks in, and now you're good to go. So you'll have to communicate. You guys learned about that. You'll be close enough where you can yell at each other. We won't be 800 feet down the street, so you'll be able to communicate with each other when you have the shot. One of the things that I wanted to just kind of tell you about to increase accuracy when you take a shot. For your purposes today, when you guys are sighting in the instrument and you're looking through the prism, you're going to be setting the crosshairs on the yellow targets. When we're actually shooting for accuracy, one of the things that you would want to do is sight on the tip. So when you have the instrument set and you're running a traverse, you'll be able to see the prism. For what you all are doing today, just shoot the prism, get it in the center. One of the techniques is when you have the vermeers and you are kind of, let's say you're spinning the dial left and right, and you're trying to center to get it right over the center of whatever you have. The center of the actual point, it looks like this. You're getting a visual here at the prism, but really the point is at the tip. So the technique that you can use is you would sight on the tip of the prism pole first. In other words, you're going to be scoping around, you're going to see the prism. You would tip the shot down and just look to see if you're on the tip of the point. Because there can be a little bit of wiggle when you're sighting on the prism if you're out a few hundred feet. You guys will see it today, you saw it last week. It doesn't always look like you're dead center. And I might just have this little bit of wave in there. So if Crystal's shooting me, I might just have that little bit of wave. But if you are sighting on the tip first, and then you just bring the vermeer up, you know automatically your horizontal angle is locked in at 0. It's locked in. So it's just something to think about. For today, just go ahead and shoot the prism. But if you really want to try to increase your accuracy, if you sight on the tip first and then swing up before you take your shot, it's going to tighten up that horizontal angle a little bit. You're going to find out how good you are today of just setting the instrument up and seeing how close to 360 that you're going to get with those 4 angles. That's why we're here. We're here to practice. So that's one little technique. I'm trying to think what else I wanted to tell you. We're each of the locations of the points, they're all a little different. So you're going to get some different setups. I've got hubs in the grass, I got PK nails in the asphalt, and I've got crosscuts and curves. So just getting the tripod over the 3 spots, I want you to just try it. I want you to be in different places. It can't be easy for everything. Maybe a little different if you've got 1 foot in the rocks and 2 on the asphalt, but you got to kind of get used to being able to set up over a foot and stuff. You'll see PK nails, you're gonna see there's cross cuts, so just use whatever point is there. How about the equipment list? Let's go through and just make sure we're bringing everything out. So total station, prison pole, take one radio per group. I put them all on channel 4. If you need me, I'll be floating around, but just call me. Someone's gonna run into some issue, it's gonna happen. Just say, Bob, can you come over and give me a hand? Plumb bob, couple of lath. Just bring a keel in case you gotta scribble anything on the ground. One field book per crew, and it's the second thing. Take one field book out, put all your notes in one book so you don't have to all be writing. When you come back in here, then your partners can take whatever you need to do your own book. If we get time, I was going to have you do vertical. Eventually, we want to get the vertical component of this, so you guys will see in there. Come back in, switch your equipment out, and grab a level. You'll come off of one of the fire hydrants, and then actually get the elevations on these 4 points. So I would say first today, let's get the traverses done. We'll come back in here and we'll work on the calcs. I think that will be plenty for today. To get the shots, come in. We'll get tables set up. And we'll try to calculate all your coordinates. Look on the back page. Here's what I would suggest. Sit with whoever you want to team up with now before you head out, and get a field book set up. Actually, all of you, just set up your own field books to have all this information kind of scripted out for your traverse. This is just a good example of what it should look like, what I'll be looking for the turn-in, what you guys are going to turn in today. That sample gives you your point numbers, the angle that you measured. Eventually we'll calculate the northings, eastings, and elevations. So for today's exercise, you're going to be getting the points and the angles. And then you've got your distances. So between the 2 points, how far apart are you? Eventually we're getting to the point where we want to have a traverse that we know all of the bearings, and the bearings distances will run through the whole calc. Who's going to work? Who's going to work with who? Who want me to?
Okay.
All right.
What's the date?
So let's do this. I'm going to go 1. So we'll go. So this team, this will be blue. 1. 2 is I think it's green. 1, 2. So we'll only need to do 3 traverses. And then team 3 is the orange. So I'm going to go with what, Derek and Gabe?
Yeah.
All right, so we'll go with Derek and Gabe. Just going by proximity. So Brian, Sam, you gonna work together. And then we're going to go Chris, Logan, and Crystal. You guys will take the orange one. So take whatever traverse shape you are going to be working with. Maybe just rough it in. Once you get out there, you'll see some of the other features. You know, everybody think you got a good line on what you need to do for your entry? Okay, shakes of heads. You think you got it for final entry? So, like we said, you guys are going to calculate all 4 of the bearings and then enter those in your field book. And we're gonna use this traverse that you worked in today. We're going to be using it for the next couple of weeks, so you guys will be using those points quite a bit. So I want to do this. On your desks, I left you guys 2 pages. I left you 2 samples. I left you 812. We're gonna basically do 812 together. So I left you this, right? So everybody's got this shape. This is 812 out of the book. Kind of jumping ahead here a little bit, but Manny, did I leave one on your table? Did I? Or if I didn't, did you?
Yeah, I don't think I got that.
Oh, you know what? Gee, I didn't get one. Sorry. Yeah, too many things go. Too many things go. let's try it again now. I have 812, which was the homework for this week. I might just take the assignment down just because we're going to kind of work through this here, these next couple of parts together. What I want to accomplish is with 812, which is this problem, it's the shape in the book, I want to be able to get everyone to be able to work all the way through the table in making the adjustments. Our goal is ultimately to determine the north and the east, the northing and the easting for all 4 of the points. And that's what we're going to use those in the data collector. We're going to use those moving forward. So your FTX is going to get you all the way out to this end of the table. But I wanted to use 812. We can kind of work this together as a sample so you can have a good example to be able to use to look for your field book entry. So here's what I want to do. I'm going to walk through this. We'll do it together. We're going to calculate together, and we're going to fill out the table together because we haven't really talked too much about how to do the adjustments. Starting here, so we have our shape, and what I did is I've already gone through and found the 4 azimuths. So I'm providing them. So our forward azimuths are going to be this one, this one, this one, and this one. And in the table, you'll already see that I put them in. So we've got a 4-sided shape. I've already listed the distances and the azimuths. Everybody okay with me? So we're going to let's work through the table. A little refresher on how we find our latitude and departure. So what? Latitude is the up and down. That's in the north-south direction. Remember that? And the departure is in the east-west. So we're finding how far north we went and how far east we went. We are going to use the azimuths. We're going to use the azimuths. You guys are going to see something else that's really neat about just using azimuths and not bearings. If we're calculating azimuths and we get some of these big angles, it's okay. We're going to end up using the big angles in our calculators just as they are, and sine and cosine function of those. You're going to see something that happens with how the sine and cosine work, positive and negative signs. So grab your calculators, and we're going to use the sine and cosine function. Let's recall what we did when we find this latitude here. What are we going to do with this? We're going to follow the table. We're going to use the angle, and we're going to take the cosine of it, and we're going to multiply it by the distance. That's going to give us this. So if we go in our calculators real quick and we take, I've already converted it to decimals, make it easy for you. If we put in 64.6667, and I find the cosine of that, because we're going to do the latitude, find the cosine of that, and I multiply it by the distance. Take that by 713.93. I get 305.48. 64. Do I have the angle right? Did I type that in wrong?
No, I was wondering.
Oh, I converted this to decimals.
Okay.
Yeah, I took the degrees and minutes and made it decimals, so you already have it there. You can just punch it right into your calculator to make it easy for you. So, yeah, in parentheses, right. So 305.48 feet. And when you punch that in, positive or negative, we got a positive angle for that. So I'm going to put a little plus there. Do the same thing for the sine, 64.6667. Take the sine of it and multiply that by 713.93. 645.27, yep. 27. So good there. So let's go through, do the same operation. Let's go to 139. Let's see what happens when we do that. So throw in 139. Everybody okay with that first step? You guys okay with these? Holler if you're not, because I have my head buried in my calculator here. So 139, 0.0167 cosine. And then take that times 606. Now, did you notice something when you took the cosine of it? Negative, right? That's okay. Hold that, just use the sign that's there. So negative 457.52. And let's do the same thing for the sine. So 139.0167, sine 606. That time I got a positive, so that's a plus 397.48.
So Bob, you're supposed to, you're grabbing the 139, the decimal form,
Mhm.
and put in times cosine of 606.06.
Yeah, the 139 is the angle. So, Bri, when you punch that in, then you're going to take the cosine of it and then multiply it by 606.06.
So let's go ahead and cosine then times. Okay.
Yes, correct. Yep.
Yeah, I didn't bring my calculator.
Okay, I got a spare. This time I got my spares. Here for midterms, I forgot to bring my extra bag, so I always have a couple extras.
Thank you.
Yep. So go ahead and do the same thing. So let's go 240. Let's see what happens. We put in 240.8333. Take the cosine of that. Did you get a positive or negative? Negative, yep. So take the negative times 391.27. So minus 190.69. And same thing for the sine, 240. Sine of it. Sine also comes negative, huh? 1.27. .66. And the last one, 296. Okay, so that's what we got for those four when you work them up. We're gonna, like I said, we are gonna hold whatever sign the calculator gives us. This is what's kind of neat about using the azimuths. We don't have to convert them to bearings. We don't have to go up here to think, am I in the north or the south direction, to be able to put the plus or the minus. You can just let the calculator tell you whether the factor is a positive or a negative when you're using azimuths. So it's another benefit of, instead of having to do bearings, we're going to do azimuths in here. Let's do this next. Let's sum up what, in a perfect shape, what should these add up to, do we think? All of our latitudes. Remember we talked about how incrementally, when we're calculating all these numbers, that we're finding out how square our shape is that we completed. When I add all four of these up, if it was perfect, what should it be? 0, right. So we're going to sum up these two columns. Let's see how we did. So if the shape was perfect, this plus all these four should come up to 0. So let's go ahead and just add up this column of our latitudes. Let's check our total latitudes. So what do you get for the sum of the latitudes? 0.33, yep, 0.33. Let's do the same for the departures, for the east and west, or the left and right. Sum up that column.
What did you do for the latitude? Add it all up?
Added all four of these, Crystal, yep. Summing up the column. 0.73, Manny?
Yeah.
Minus, yep. And this one we got a minus 0.73 feet. I want everybody to kind of catch up a little bit. Guys, we're working through the example that I got there on here. It's 8.12 that we're working on. So if you guys want, you can use the sample that we got. So If these don't sum to 0, that means they're kind of off, right? Something's a little off distance-wise. We got a good shape, we have all of our angles, but the lengths and the angles, the measurements, we were off. So we're 0.33 feet too big in the north-south direction, but we are 0.73 feet too short when we sum up everything in the east-west direction. So that just says our traverse that we shot, it doesn't close. It's not perfect. What we need to do is take these adjustments and we need to do what's called a balance. We need to balance them out. We need to somehow get this difference here averaged into these 4. We need to take this sum here and get it balanced into here. It's kind of like a percentage. If you just think about, we're 33 hundredths off in all of our latitudes, so our up and our down back to our shape. Somehow we want to blend that. We want to blend it. We want to put it in appropriately into these 4 numbers so that this comes out to 0. Does that kind of make sense? We're basically just averaging is what we're doing. And the same with this. Our 73, we've shrunk. We came in too small. Our shape is too small. We need to make it grow, but we want to make this grow in some sort of proportion so when we change these numbers, they come out to 0. That's the goal. So Manny says divided by 4. Well, we could, but what's unique about this? That's a great point, Manny. So if I was to just take this 0.73 and I said, what if I just blend it into all 4 of these numbers? Let's look at our lengths. Well, this leg here is 700 feet. This one's only 390. This is 606, 713. So they're all different, right? So all of our leg lengths in the shape are different. So we wouldn't be able to just kind of average them. What we want to do is kind of prorate it, essentially, is what we're doing. So to prorate it, and that's what's called the compass adjustment. Let's take a look at your crib sheets. This is how we do it. It's just what we're going to do is we're going to find the percentage and we're going to balance them out. And I know I'm going to move a little quick here, but it's just I don't want to hold you guys past 12:30. So the compass rule adjustment says we're going to balance that difference out. So let's just look at the latitudes and take a look at the formula, what we have to do here. So we ended up missing, we're 33 hundredths too big. So that's our sum of our latitudes. The way we average it is we're going to say the length of our segment, which would be, let's say this, or this, or this, or this, divided by the total perimeter. So kind of along what Manny was thinking, well, we could divide this and just throw this in and divide it by 4. But if we take the length of the segment over the total length, then let's go ahead and let's sum this up. What's our sum of our total length around the perimeter? So let's add that up real quick. 713, 3, 606, 106, 7, 781.18. So 2492. 49 feet. Everybody okay with that? 2942. So this is our total length. So what is the ratio? And that's really what the compass rule adjustment says. It says let's take the ratio of this piece of the traverse divided by that. So let's just take right now 713.93, 713.93, and let's divide it by the total length, 2492.49. What do you get? Is that? Let me run that again, man. I got a little different number there. 2.4 divide. I get 20. Try that again, Manny. I get 28.286. Does anybody else get that? Crystal, 0.286. 0.286. What does that say? That says 713 divided by this. It's essentially 28.6%. So it's 28% of the total length. So what if we take this ratio and we multiply it by 0.33? 0.33. What do I get? I get 0.095. 0.095. Let's jot that down. 0.095 feet. So what we did is we just took the ratio. We said, what's the ratio of this length over the total length? Let's divide this piece up into that. So 33. So it's 28. This is basically 28.6% of this ratio. Let's do the same thing. Let's take 606.06. 606.06. Let's divide that by the total length. 24, 92, 49. So I get what? 0.243? 0243. So let's take that times 0.33. You get 0.08 feet. Let's do that for the last two. I'll let you everybody punch them up on your own. So 391.27 divided by the total length. 0.33 multiply. Oh. And this one I get 0.10.
Okay.
You guys, everybody okay so far?
How are we getting these again? I've
Walk through this? Oh, because you guys are writing? Okay. We want to take this, 0.33, and we want to distribute it appropriately by these lengths, whatever these percentage of the lengths are. So we said if I take 713 divided by the total length of 2492, punch that in real quick, Derek, if you guys are working on, if you guys need to. So 713.93 divided by the length, 2492.49. And what do you get?
0.2864.
Correct. So 0.28, so that's 28%. So that's basically saying this is 28% of the total length. You follow that?
Oh, I
So
see.
multiply
Okay.
that by 0.33.
Okay.
So we're prorating.
0.09.
0.09, right?
Okay.
So what we're doing is, everybody, just now that you have a total set of numbers here, we're just taking this 0.33 and we're prorating it by what percentage do each of these four lengths of the traverse contribute?
Okay.
Does that make
Okay.
sense?
So it's in the same process.
Same process, yep.
606.06 divided by the total,
Yep,
multiplied by 0.33.
33. Yep, distribute them.
So for the other one, you do the same thing?
For this side here,
Yeah.
yeah, we'll do the same thing for here. This 0.73, if you want to work through the numbers on your own, 0.73, we're going to do that exact same thing. It's the length of the segment divided by the total length times that number. So go ahead and run those out. Let's see what everybody gets. And you can tell I'm not putting any signs on anything right now either. I'm going to scoot through these because I got them here. Oh, 2, 3. Is that 2, 3? 2, 3. So let's do this. If you guys want, you can do a little quick little cheat code here. So just drop in these numbers. But the process is the same. I just got them pre-calc'd up. Add them up. So let's sum up. Go ahead and sum up the columns. And let's see what we get. 095. Uh-huh. You guys should see some common numbers coming out of this. The 0.33 here, Manny?
No.
0.325, right? Which is 0.33.
Let me double check me, Manny. Which one?
The compass adjustment and sea latitude,
Okay.
I got 0.325.
Oh, for your total?
Yeah.
Yeah, okay. So 0.3, I'll run that out, sure.
Yeah.
Yeah, that's fine. I had it to the 100, so 3, if you round up by 325. It'll round up. It'll round up to 33. And let's go ahead, Crystal, say it again. You okay?
Sorry, how do you do the report?
So the departures would be the same process. we would take the 713 divided by the total length, but in this case we're going to multiply it by 0.73.
I see it.
We'll talk about the sign when we get everything summed up. So Sam, you're on it. So these are just the numbers right now for running that math out. Let's total this column up and see what we get. 0.21, 0.18,
They have a
0.11,
relationship.
0.23. Yep, you guys are starting to see a pattern here. So this turns out to 0.73 feet. Essentially what we did is we took this 0.73 and we just prorated it accordingly for what the lengths of the segment were. So what Manny said initially is if we just took the 0.33 and we divided it evenly about these, it wouldn't distribute it appropriately as to how far the lengths are. Does that kind of make sense? We're blending it. We're prorating this total number based on the individual lengths of the segment. So you can see that they are the same. So we've essentially converted these to a length. Now, Sam asked about the sign. Here's the one time that you have to think when you're inside this table. What did we say when we totaled up all the latitudes? We got a 33 hundredths. Is it a plus or a minus? It's a plus, right? Essentially, when we added all of our stuff up, our traverse was 0.33 too big. It was too big. We need to shrink it when we do our adjustment. So this came out to 0.33. Our whole traverse is too big, and I should be going this direction. It's too big to the north. We got to shrink it. So to shrink it, we're going to make these negatives. So just turn those into negatives.
Oh,
Because our traverse in the north-south direction was too big by 0.33, that's what came here. So the adjustment we want to make is shrinking it. So all of these numbers we want to shrink to get it down to 0. Does that make sense? Crystal? Yvette? Holler at me. Just think this through again. When we do all of this summing up, it just says that all of our north directions are too big. We were too big by 0.33 feet. So when we do our adjustment, we want to shrink everything by 0.33. So we turn these into negatives. So it's more intuitive. It's just thinking about what the process is. Let's think about the latitudes or the departures. The departures, what happened? Our shape was negative 0.73. We were too short. Our was too short. So the balance that we want to do is we want to grow it. We want to take that 0.73 and grow it. So these are going to be positives because we want to make it bigger. Does everybody follow that kind of mindset? This is the only time of the table that you kind of have to think about the data that you have. Now, so we are going to adjust this latitude by this dimension. We're going to adjust this latitude by this dimension. We're going to do that on all 4 of these and transfer them over. So let's just do the math here. 305.48 minus 0.095. So 305.48. We're going to shrink it by 0.095. You guys can round that if you want. So I get 305.39, 39 feet. So this is our new latitude. We've balanced it is essentially what we've done. We've changed the initial latitude that we calculated by this adjustment factor. This is our new latitude. Let's do the same thing and let the signs be what the signs are. So minus 457.52 and go ahead and take away minus 0.08. Take away 0.08. 457.44. Oh, wait a minute. No, I'm wrong. Yep, it should be bigger. I'm sorry. I punched that in wrong. 457.52. Yep. 0.8 minus. That should be 0.60.
so do we, okay, yep, carry the sign.
Carry the sign. Yep. How to get 0.60? Punch this in, Manny. Minus 457.52 minus 0.08. So we're starting with a negative.
No, I did .18.
I did the same thing. Oh, you did .18. Okay.
Yeah, that's fine.
So same thing. Let's do C to D. So minus 190. 69. 5. I get minus 190. 74. And the last one. .96. That's plus.
And then basically the same thing.
Yeah.
for the
So let's do
department.
this. I'll say this. Let's sum this column up real fast because I'm coming up against the clock here. I don't want to keep you. So if you sum all those numbers up, and if you have a stack in your calculator, you're actually going to notice you might be able to sum some things up a little quicker. 305.39. How about that? 0 point. I get 01. Because what happens when we balance our latitudes and we sum all these up and we put this increment into it? What should it be? 0. Should turn out to be 0. If we balanced everything right and now we sum up our balanced latitudes, this column should end up being 0. So we'll do the same thing for the departures. Sum them up, and that should be 0. So these are the new numbers. I know I had to move fast, but I had to move fast. I'll throw it up on YouTube in case you want to walk through.